All right, recording webinar. Good morning and welcome to USA Clean's webinar on the basics of corded electric machines. My name is Jared Anderson and I am a technician here at USA Clean. And I'd like to remind you all 4 things right now. Number 1, all attendees will be muted during the presentation. Please save questions until the end of the webinar presentation. All your questions need to be asked through the chat feature and answers will be emailed to you after the webinar. All right, let's begin. Our overview, we're going to cover corded machine types, the power system's flow, troubleshooting the electrical issues, the tools list, a few simple repairs, and recommended maintenance. Now, corded electric machines, you might see 4 types, vacuums, extractors, buffers, and the ever-popular swing machine. Basic power flow is a basic AC system. Your cord is going to have 3 wires, black, white, green. Green is going to be your ground. Your black wire will probably flow through a switch, possibly another circuit breaker or a fuse, to your motor or vac motor or whatever power system you'll be using. Some machines will use a DC motor, and when they do that they'll put in a rectifier in the middle. Now a rectifier will convert AC to DC. DC power goes to the direct current brush motor or vac motor or pump. A few other machines will run a capacitor system for the motor using a start capacitor and run capacitor with a relay in between. These are usually AC motors. Basic tools you'll use. You'll need a good multimeter. Fluke's a good brand. Standard socket set, wrench set, standard and metric. Screwdrivers, flathead and Phillips. A good set of wire crimpers and strippers. And you should also have some electrical tape and zip ties if you need to tidy up the wiring. First thing you run into is a power cord issue. Usually be a bad plug with missing prongs. They get kinked and the wires get exposed. Usually what happens with the kinks, the wires will break, you won't see it, so there will be no continuity in the cord. 9 times out of 10 this is because the person who used the machine unplugged it from the wall with a yank and then wrapped the cord up from the plug end. What this does, that puts a twist in the cord, and by the time you get back to the vacuum or other machine, that twist has kinked all the way internal into the 3 wires inside the cord. Pretty easy. If the cord's damaged, just replace it. Switch issues. Switch issues you're usually going to have about 2 different types. External. And what that is you can't flip the switch, so to speak. It can be stuck. It could be broken. The toggle could have broken off. The button could be missing. That's an external issue. Internal, the action will move, but you won't have continuity through the switch. That's going to be hard to see because if the break internal, you'll need the multimeter to probe your ends to check for continuity. Sometimes you have burning that you can't see from the outside. It'll burn on the inside, and that'll ruin your continuity as well. So to troubleshoot, you're going to set your multimeter to continuity. That's the symbol that looks like a couple curved lines in ascending order. You'll connect your leads to the prongs of the switch, flip the switch off and on. The multimeter will beep with the switches in the off position. The multimeter will be silent in the off position. You can also see a readout of an ohm resistance on the readout of your meter too, but the auditory beep is the best way to know. Rectifiers. I discussed rectifiers briefly in the beginning. Rectifier will convert AC to DC power via diodes. Without getting too complicated, AC is a waveform, DC is a straight line. Rectifier knocks off one peak of the wave and then flips it over. So, when you have a bad rectifier, number one symptom you're going to see is a wall breaker will trip. In fact, that happens so often in the shop here that we're all tuned in to hear that breaker pop when someone brings in a machine and plugs it in. And invariably, one of us will just yell out rectifier when that happens. When a rectifier goes bad, the diode inside is what fails. So you got two opposing AC charges that come in back into each other. And that's why I short out the wall circuit and nothing on the machine. The troubleshooting rectifier, set your multimeter to the diode setting. That's going to be your standard diode symbol, which is going to be a triangle with a vertical line. Now what is critical here is which way you put your probes, because a diode flows one direction but not the other. So if you see in the diagram how we're checking the four individual prongs on the rectifier, we actually hit each one twice based upon which direction that diode is biased. Capacitors. A capacitor is a device that stores a charge. Now when they're used in this case, a start capacitor or a run capacitor, a start capacitor will give an extra boost to the machine at startup. Get that motor spinning quickly. Run capacitor will vary out, smooth out the variations in the voltage and the amp demands, current draw demands of the motor as it goes across the floor. So the symptoms of a bad start capacitor is it's going to be really slow to start, and it may not even start at all. A bad run capacitor is probably going to waver in speed up and down the motor, and it could even stall the motor. To check a capacitor, you'll flip your multimeter to the capacitance setting, which is going to be a vertical line with a curved line to the right. It's also important to discharge your capacitors before you test, and easiest way to do that is to take an insulated tool like a screwdriver, and you're going to short out the probes, short out the two leads. You might see sparks, you might not. Be careful when you do this. You don't want to burn yourself. The unit of measurement in most capacitors on these machines is going to be a microfarad. The standard is a farad. It'll be an F, capital F. The rating will be printed on the side of the capacitor, and normally it could be within a percentage, 10%, give or take, up or down. As long as your capacitor is within this, it'll be good. If it's out of spec, you'll need to replace it. Relay issues. Relay. A relay is an electronically controlled switch. So you'll have similar issues as a normal flip switch, toggle switch, push button. But like the internal problems with the switch, they're going to be hard to see because there's no outside physical activation of the relay. It's all internal in the magnetic coil that the electricity controls. Most relays are going to have two sides, two posts each. Power flows through what's normally called a signal side or coil side. Those are going to be the smaller pins, and that controls the electromagnet on the power side or switch side. That's usually a larger post. Earlier when I said there's some relays that are between two capacitors. The switch is between a start capacitor and a run capacitor. If that relay goes bad, it'll ruin both. And normally, especially in the case of Tasky, they recommend replacing all three, both capacitors and the relay between the two, just to make it easy. We'll test just like switches. We'll set to continuity. And here we will have to apply power to the signal side or the coil side. And once we do that, the switch will engage and we'll get our normal. If it's on, we'll get the beep. If it's off, we'll get silence. You can also run into relays that don't behave like this. You'll have a normally open and normally closed relays. Normally open basically means that the circuit is not complete until power is applied. A normally closed relay, the circuit is complete until power is applied, and then it opens the circuit. So that's actually kind of a illogical wording. You would think an open switch is on, but actually it's the opposite. An open relay is off until power is applied, and a closed relay is on until power is applied. Opens it up, breaks the circuit. Breakers and fuses. These can be a lot of fun because normally you can easily spot it's tracking down the issue that's the problem. Power will shut off right away. Of course, it may not even turn on at all. Fuse is usually easy to replace, provided you have a fuse with you. For breaker trips, if you're lucky, just reset it. Sometimes the breaker gets damaged. It may overheat beyond what its thermal capability is, and you could run into won't be able to reset the circuit breaker, or if you are able to reset it, you still have no continuity, or you'll have a breaker that trips even when there's not an excess of current applied. In the normal use of the machine, a tripping breaker or blowing fuse might happen when you hit a high spot or high resistance. If your brush hits a carpet, goes over a threshold. Unevenness in tile floors can do this too, especially with buffers. Another cause is a simple short in the wiring. Melted wire, a loose lead touches a ground where it's not supposed to, and that'll trip a breaker too. On to the motors and pumps. Some issues with a bad motor or pump. Usually it's the sound. Sound's the first thing that'll let you know. You can hear a grinding sound, a rubbing sound. The pitch may get higher or lower, but if you use the machine daily, you'll notice when the machine's sound changes. And you get bad bearings go bad. There's fans, cooling fans inside motors that can rub against housings. The rotors, the windings itself, those can come loose or melt and start to make contact. You may have bad smell. That's usually from the arcing inside. Bad carbon brushes. Carbon brushes, which is a feature of a DC motor, they tend to wear. Actually, they're made to wear and made to be easily replaceable once they wear. They'll get to a spot where they don't make contact anymore, and you may look and see it looks like it's making contact, but there's just enough of an air gap between that carbon brush and the rotor or the aperture where no electricity flows through and the motor just doesn't spin. Or you'll have a carbon brush that's got chipped or cracked, or that its surface is not smooth, and that'll cause arcing also. That arcing will go away once that carbon brush wears down. And you can also have bad wiring. Well, the leads that run into the motor, they can have their own issues where they have bad crimps, bad solder. Usually that's easier to see, unless it's inside the actual motor casing. That can be a little more difficult to deal with. When you're trying to troubleshoot a motor or a pump, if the motor or pump doesn't run, it's best to check the other components first, and that's why in the beginning we're looking at the switches, and then the relays, and then rectifiers and all that. If all those individual pieces are fine, then we need to look at the motor. If it's a DC motor, let's look at the carbon brushes. Like I said, they're really easy to change out and also fairly inexpensive. If you have an AC motor where you don't have carbon brushes to check, or carbon brushes are fine, and then we're probably looking at the motor to be replaced. Certain machines, especially swing machines, that are normally relatively inexpensive, that motor is the most expensive component. Sometimes it's better to just replace the whole machine, save you the time and trouble trying to change that motor out. Okay, let's get into maintenance. Daily. Now, like I said, you're going to run into cord problems a lot, so we're going to inspect the plug and cord for damage, replace if necessary, check hoses for damage or clogs, need to clean debris out from brushes. You got a lot of debris wrapped up in there, a lot of hair, carpet fibers, anything gets wrapped up in that brush, and that can raise your amp draw. That could burn your bearings out. Check and replace the bags. We get a full bag leads to a clog, and a clog works its way down the machine, and then we see the machine doesn't work, the vacuum doesn't work until we get that replaced, or until we find a clog. Clean debris from filters. Goes along the same lines as keeping the bags clean. Dirty filter impedes airflow. Impeding airflow can cause issues with the vacuum. Yearly, we want to check the carbon brushes and replace it if necessary. Normally on a vac motor or a brush motor, you replace the carbon brushes once, you're good to go. If you keep it up to where you have to replace them a second time, it might be about time to replace the motor. Alright, so in summary, cord electric floor machines, various types include vacuums, extractors, buffers, and swing machines. Power flow can be interrupted by faulty components, cord switches, rectifiers, capacitors, relays, breakers, fuses, motors, and pumps. The electrical issues can be diagnosed and solved with just a few tools, including a multimeter, screwdrivers, wrenches, crimpers, tape. Issues can be avoided through regular maintenance, like keeping all cords, hoses, brushes, filters, bags free of debris or damage. All right. Thank you for attending this webinar. Like I said, my name is Jared Anderson. I am a tech here at USA Clean. I'd like to thank you all for attending and remind you that we will be answering emails to all your questions, and feel free to visit usaclean.com or call 1-800-USA-CLEAN for more information as well.